Welcome to The Explainer. Have you ever wondered how an AI like ChatGPT can actually follow a long, complicated conversation and remember what you said paragraphs ago? Well, the secret sauce isn't magic. It's one of the biggest breakthroughs in modern AI, a concept called the attention mechanism. And today, we're going to pull back the curtain and see exactly how it works.
All right, here's our game plan. First, we'll look at the huge memory problem that kept older AI models stuck. Then, we'll get into the brilliant solution: attention. We'll break down how it actually works with these things called queries, keys, and values, see what happened when models started paying attention to themselves, and finally, we'll see how this one idea literally kicked off the entire transformer revolution.
Okay, let's get right into it. To really appreciate why attention was such a game changer, you've got to understand the problem it was built to solve. And there's no better way to see that problem in action than with a task that seems simple on the surface: language translation. So check out this super simple example. In English, we say the black cat. But in French, the grammar is different. The adjective comes after the noun, so it's le chat noir. Now, an older AI model chugging along one word at a time would often mess this up. It would see the, then black, then cat, and just translate them in that order, with no ability to look back and realize, oh wait, I need to reorder this whole phrase. This is a perfect example of the model completely losing context. So why? How could a machine get something so basic, so fundamentally wrong? Well, it wasn't just a simple programming error. This was a deep architectural flaw. So what was really going on under the hood that made these early models so blind to context? The core of the issue is what we can call the RNN bottleneck, and you can see it right here in these 3 steps. Models like recurrent neural networks, or RNNs, would read a sentence one word at a time. Then, and this is the crazy part, in step 2, they try to cram to squeeze the meaning of the entire sentence into one single fixed-size piece of data. Then in step 3, that one little vector was the only piece of information it passed along to actually generate the translation. Think about it. It's like trying to summarize an entire 2-hour movie in a single sentence, and then asking someone to rewrite the entire script based only on that sentence. Of course, you're going to lose all the important detail. So to fix this massive memory problem, researchers came up with this incredibly elegant solution. And it was actually inspired by how we as humans process information, right? You don't listen to an entire long sentence and then try to remember it all in one go. You focus on the important parts as you need them. And that, right there, is the big idea behind the attention mechanism. You can think of it like giving the AI a new superpower. Instead of being stuck with one flawed, compressed memory of the past, attention gives the model the ability to look back at the entire original sentence at every single step of the way. It can now dynamically decide for itself which words are most important for whatever it's trying to do in that exact moment. This slide just lays it out perfectly. On the left, you've got the old way, that information bottleneck we talked about. But on the right, with attention, that bottleneck is just blown wide open. The part of the model that writes the new sentence, the decoder, now gets direct access to the context from every single word in the input for every single word it generates. That whole forgetting problem, it's basically solved. Okay, so how does the model actually decide where to focus? It's not just random guessing. It's this really clever, calculated process that uses 3 special components that the model learns for every single word: queries, keys, and values. Let's break down what those are. The library analogy here is perfect. Let's say the word the model is currently working on is the query. That's like you walking up to a librarian and asking a question. Now, to find the answer, you're going to look at all the books on the shelves. Each book has a key. That's like its title, a label that tells you what it's about. The model compares its query to every single key to see which ones are the best match. And once it finds the most relevant books, it pulls out the value, which is the actual information, the content inside those books. And here's basically how that library search works under the hood. In step 1, the model takes its query, the word it's focused on, and compares it to every other word's key to get a score. A high score means, hey, this is really relevant. Then in step 2, it does something simple. It turns all those scores into percentages that add up to 100. We call these attention weights. So a super relevant word might get, say, 70% of the attention, while a useless word gets 1%. Then in step 3, it just combines the values of all the words using those percentages as a guide. And that creates the final output in step 4, a brand new representation of the original word, but now it's supercharged with rich context from all of its most important neighbors in the sentence. This whole mechanism was so incredibly powerful, it led to a really game-changing question.
You see, the first attention models still use that old, slow RNN structure. So a few researchers asked a brilliant question. What if we just got rid of the RNNs completely? What if a model used only attention and had it just look at itself? And this led to the idea of self-attention. It's exactly what it sounds like. The queries, the keys, and the values all come from the exact same input sentence. This lets the model build this incredibly deep, complex map of its own internal grammar and the relationships between words, all without needing any other clunky architecture to hold its hand.
And this quote captures the exact moment that everything changed. In 2017, a research paper came out with this unbelievably bold title: Attention is all you need. And it wasn't just some catchy phrase, it was a declaration. They had proven that you could throw out all the old models and build absolutely world-class AI using nothing but this powerful self-attention idea. And getting rid of that sequential, one-word-at-a-time processing was a massive deal. Why? Because that step-by-step process was fundamentally slow. You just couldn't speed it up. But self-attention, it can look at all the words in a sentence at the exact same time. And that meant the whole process could be run in parallel on modern hardware like GPUs, which dramatically accelerated how fast we could train these giant models. And to make it even more powerful, they came up with multi-head attention. The best way to think about this is like giving the model several sets of eyes to read a sentence with. One head, or one set of eyes, might learn to focus on grammar, another head might focus on tracking who's doing what to whom, and a third might focus on the deeper meaning. It's like reading a sentence over and over, each time looking for a totally different kind of connection between the words. All right, let's bring this all home in our final section. Let's see how this whole stack of brilliant ideas comes together to create the transformer architecture, the engine that is powering the AI that is changing our world right now. So this self-attention mechanism, this is the absolute foundational building block of the transformer. This design, which came from that Attention is All You Need paper, is now the architecture behind basically every single major large language model you've ever heard of. That T in GPT, it stands for transformer. Models like Gemini, Claude, they're all built on this core idea. And the impact was just immediate and profound. Transformers didn't just nudge the field forward a little bit, this was a seismic shift. They produced much higher quality results, they could be trained on way more data because they were so parallelizable, and they did it all in a fraction of the time. This was the spark, this was the catalyst for the entire generative AI explosion we're living through today. So the crucial thing to take away from all this is that the simple, really elegant idea of attention, of just letting a model weigh the importance of its own inputs dynamically, it solved a fundamental memory problem and completely unlocked a new era of AI. It gave machines a powerful, flexible new way to understand context. And it leaves us all with this one thrilling question. What's going to be the next attention is all you need moment that pushes AI to a level we can't even imagine yet?